Good morning dear students. So today we will have class on exemplar problems. This is your video of Karnataka CET 3rd. Fine. So in this one I am completely going to cover all the exemplar problems and how to trace them. What will be the answer for each options. We have to find out the correct option. Fine. So in that one exemplar I have first problem. Which of the following is considered as correct IUPAC name? We have a set of 4 molecules. Out of those 4 molecules I have to find out the correct option. So see here, I have 3-ethyl 4,4-dimethyl pentane, 4,4-dimethyl, 3-ethyl pentane, 5-ethyl 4,4-dimethyl, heptane. All these are heptane. In the sense there are 7 carbon atoms to which respective substituent groups are directly attached. So when you consider these molecules, you can see here that I have 3-ethyl. I've written the structure of this one. So with this structure itself, I'll explain all the rest of the molecules also. So 3-ethyl, in the sense E will be alphabetically, it will be coming first. So E should get lowest number. So ethyl, 3-ethyl will be written here. Then I have 4,4-dimethyl heptane. So 4,4-dimethyl, in the sense on the 4th carbon atom, 2 methyl groups are directly attached. So it is referred to be first molecule. Fine. Then you can see here 4,4-dimethyl 3-heptane. Here yet D comes first. D will be coming prior to E, but we do not consider this di, which is considered as a prefix. I have written here, this prefix will not be considered while naming the organic molecule. It is only the alphabetically which element, which alphabet is present at the first of the name of the molecule we have to consider. So it is M. So here it is E. In the sense E would have come first, but M is coming first. And as M is coming here, it would have got a lower number. In the sense ethyl will be getting the higher number, but that is not happening here. So the reason I have written here, while writing the IUPAC name, prefixes like di, tri, tetra are not going to be considered. So in the sense this is 4,4-dimethyl they have taken here. If I take this as a 4th carbon atom, I will be writing dimethyl. Okay. Here they are mentioning 3-ethyl. Here it is, they are mentioning here 3-ethyl C2H5. But while naming this one, while naming this term, that is dimethyl, we do not consider di. Only we consider M. M would have come later. M that would have come later, but it is coming here at the 4th position. So this will be not considered as a correct option. Here at least 4-ethyl they are telling here. 5-ethyl they are telling here. 4,4-dimethyl. Dimethyl, M is coming here, E is coming here. Alphabetically E has to come first. E has to come first in the sense it has to get a lower number, but it is getting higher number. So this option is also wrong. Then we have 4,4-bis methyl, 3-ethyl. Again ethyl would have got 4 number and methyl would have got least number. This option is also wrong. This is the only option left. What I have written here, structure of that molecule, that is the correct one, that is 3-ethyl 4,4-dimethyl heptane. Only this one will be considered as a correct option. So moving to the next one, let me rub this one. Again we go for the IUPAC names itself. So let me consider the second option here, that is IUPAC name for this structure. Structure is being given. This is the exemplar problem what I am writing here. It is second one, IUPAC name. IUPAC name. Okay, IUPAC name for CH3 C double bond O, CH2 C double bond O, OH. Okay. So 2 CH2 are there. Fine. So here I have functional group carboxylic acid. As I have carboxylic acid functional group here, there are 4 options are being given. I'm not going to write the rest of the 4 options. I just directly tell you which option will be correct, you have to choose. If I would write the correct name of this one, the rest of the options definitely will become wrong. Okay. So this is going to be placed number 1 and these 2 are placed 2 and 3. So let me write like this. See here CH2, CH2, right? This is first number, this is my second number carbon atom, this is third and this is fourth, right? Fourth, and this is considered to be fifth one. We know that it is the parent chain. This is considered as a parent chain. Parent chain contains how many number of carbon atoms? So 5. 5 carbon atoms. In the sense it is having functional group carboxylic acid, pentanoic acid we can call. But at the fourth carbon atom you can see here that oxygen is directly bonded. So what will be the name of this molecule? 4-oxo-pentanoic acid. 4-oxo-pentanoic acid. Okay, this is the correct option. Out of 4 options, you have to choose the correct one. Like this, we have to solve the exemplar problems. Let me consider the next one here. So third question, if you are considering IUPAC name, IUPAC name. This is my third question. IUPAC name for this structure. I have benzene skeleton, right, with which I have 3 substituent groups. This is NO2. Here I have Cl. Okay, so 3 substituent groups I have. Oh, how we supposed to name this one? See, if you consider, this is considered as methyl group. Okay, whereas this is considered as nitro and it is considered as chloro. Okay, so priority wise C comes first. So C comes first in the sense we have to give number 1 and this is number 2, this is number 3, 4, 5 and so on it goes. So what should be the name for this one now? This name we will be writing for this one starting from Cl. 1-chloro we will be taking. Okay, 1-chloro, and then we have nitro group as well, we have methyl group. So out of these two, which one will come prior according to alphabetical order? I have methyl, right? M comes first, then N comes. So the reason why we will be taking the name 1-chloro, 1-chloro, fine. 4-methyl, 1-chloro, 4-methyl. I will be writing 1-chloro, 4-methyl. Then we will be taking 2,2-nitrobenzene. So this is considered as exact name of this molecule. This will be your option A. Likewise, C, D will also be present. B, C, D. As we know, the correct option or correct name of this molecule is itself this one. We are going to ignore the rest of the molecules or rest of the options. So correct option is this one. So we'll move to next after this one. Next question let us consider. Let me consider next question, that is electronegativity of carbon atom depends on their state of hybridization. Electronegativity of carbon is depends on their state of hybridization. We all know this one, right? State of hybridization. In which of the following compounds? 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 Carbon marked with asterisk. Carbon marked with star. Carbon marked with star is most electronegative. Is most electronegative. So here question is such that we have to see all the four options. Out of those four options, we have to find out which carbon atom is most electronegative. Based on that, we are going to get the option, that is electronegativity of carbon is depends mainly on their state of hybridization. Okay, we have studied sp3 hybridization, sp2 hybridization, sp hybridization. We all know sp3 is most electronegative, generally covalently bonded, right? We have sp3, sp2 and sp. Okay, so in the sp triple bond, sp2 double bond, sp3, we will be having the single bond. So here I have four options. You can see here CH3, CH2, CH2, CH3. Here I have star. Then I have CH3, CH double bond, CH. Here I have star. Okay. Then here I will be having CH3. You can see here CH3, CH2, C triple bond, CH. Here you will be having a star. Fine. Then you can see here CH3, CH2, CH double bond, CH2. Here you will be having the star. Okay. So I have four options, A, B, C and D. Out of these four options, we have to find out which one will be considered as electronegativity of carbon is depends on their state of hybridization. In which of the following compounds carbon marked as asterisk is most electronegative? Electronegativity increases. Likewise, sp hybridized carbon atom will be most electronegative. This is least, and then we have very less electronegative in nature. So you can see here which one will be sp hybridized carbon atom. If you see here, all are sp3 hybridized, no sp carbon. Here it is said to be sp2 hybridized, no sp carbon atom. Here also it is sp2 hybridized. This is sp2 hybridized. This is also sp2 hybridized. This is sp3 hybridized. Only the option left is considered to be sp hybridized is a C. So this will be considered as a correct option. Fine. So once we complete this one, we'll move to next question. So next question we are having here, in which of the following functional group isomerism is not possible? In which of the following functional isomerism is not possible? Okay, this is my fourth question, right? Let me consider this is my fifth question. Let me consider the options. First, A, I have alcohols. B, I have aldehydes. Okay. Then C, I have alkyl halides. And then lastly I have D, cyanides. Okay. Cyanides, right? So here if you see alcohols, if you are considering like CH3OH or CH3, if you are considering C2H5OH, ethanol, C2H5OH you are considering, it is ethanol. So the functional isomer for this one we can even write CH3O, CH3, both have the same molecular formula. They are functional isomers because we have a functional group here, alcoholic group, whereas here we have ether as a functional group. Moving to next one, we have C2H5, I can write here CHO. Similarly aldehyde I have here. Similarly I would consider C double bond O, CH3. Ketone is also possible. C2H, how many? 6, right? C2H6O, yes, it is balanced. So now this is considered as an aldehyde, where it is considered as a ketone. So both are considered as different functional group molecules. So functional isomerism is possible here in these two cases. Coming to alkyl halides. Alkyl halides, how we write? We directly write Rx, or I would directly write here CH3Cl. This is the example. How you change? Not possible. So cyanides I have here C triple bond N. Here I will be having R. Okay, like this I can write, or even I can write here R N C. So I can interchange the places also, in the sense that I may get here cyanides or isocyanides. Functional groups, functional isomerism molecules are possible. It is only alkyl halide with which we cannot change any of the position with respect to halogen. So the correct option is alkyl halide. With the help of alkyl halide, we cannot write any of the functional isomers. So correct option where we cannot write functional isomers is for alkyl halides. Rest of the all molecules, they will possess certain functional isomers. Moving to next question. So let us consider, that is sixth question. So sixth question is directly I will read out. You can see your NCERT textbook, that is fragrance of the flowers is due to presence of some steam volatile organic compounds called as essential oils. They generally soluble in water at room temperature but miscible with water vapor in vapor phase. The suitable method for the extraction of these oils, the flowers, is. So it is considered to be a kind of question which is arised from the purification techniques. You have certain purification techniques in organic chemistry part. There these questions have been arised. Like we have studied there, steam distillation, crystallization. For a reduced syllabus, this part is completely deleted. Only the thing is for NEET and JEE such questions can come. But for CET it is no issue. You cannot be asked such questions. Directly skipping the seventh question also, that is during hearing of a court case, judge suspected. That is, this is mainly based on thin layer chromatography. Thin layer chromatography will explain the above phenomenon. I think this also not going to be asked for your examination. Then eighth also, principle involved in the paper chromatography, that is also not going to be asked. Only the next one, what is the correct order of decreasing stability of following cations? So correct order of following cations, a related question I have explained in our previous video, last video. You can refer there. Then we have next one, in which of the following, 10th question of exemplar, 10th question of NCERT exemplar I have here, that is, in which of the following compound, 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 the carbon marked compounds, carbon marked as star, okay, carbon marked as star is expected to have greatest positive charge, greatest positive charge. So this is one of the nice question I can say here. So one more thing I wanted to tell you, students, if you feel while writing the things becoming very slow, when you are exactly directly revising for your examination, means you can keep this video speed of playback speed, you can say, that will be kept 1.5, 1.75 or 2x. You can increase the speed of the video and you can see there, so that your time will be reduced. Seeing the video time will be reduced. Okay, so here I have certain options. Fine. So in that one I have first one CH3, CH2, Cl. Then I have B, that is CH3, CH2, Mg, Cl minus. Okay, this is marked as a star here. Here it is marked as a star. Okay, then C I have CH3, CH2, Br. Here I have they have marked this one. Lastly, I have CH3, CH2 and CH3. Here what they are asking here, most shows greatest positive charge. Greatest positive charge in the sense halogen must be showing the negative inductive effect. It will be grabbing the electron towards itself. I think you remember positive inductive effect and negative inductive effect. Due to highest negative inductive effect, what will happen? Electron negative atoms will be grabbing the electrons towards themselves, so that these asterisk or starred carbon atoms will be getting the positive charge. So out of these, which one will be showing the most positive charge, they are asking. Out of 4, what will happen here? This Cl is directly attached. Here it is attached to Mg, but it is not directly attached, so we cannot consider this one. Br is there. Br is less electronegative than Cl. Here at least no any of the halogen atom is present. As Br is directly attached and it is most electronegative also, first option itself is the correct option, in which this CH3 will be possessing most positive charge. So first one will be considered as the correct option, right? So we move to the next one with this next question, 11th question. So you can see here 11th question. So ionic species are stabilized by ionic species are stabilized by dispersal of the charge, stabilized by the dispersal of the charge. Okay. Which of the following carboxylate ion is most stable? Which of the following carboxylate ion is most stable? We have to find out most stable carboxylate ion. Okay, let me write the options here. Option A. So in this option A, I must write CH3, C double bond O, this is O minus. Then B, Cl it is CH2, C double bond O, it is O minus. Then C, F I have CH2, C double bond O, O minus. Then I have D, here I have F, here I have carbon CH, here I have F, then I have C double bond O, then it is O minus. Okay, so these are the 4 options I have here. So you can see here, which of the following carboxylate ion is most stable? They are telling most stable in the sense higher should be the negative inductive effect. Andre ಇಲ್ಲಿ ನೋಡಿ O minus ಒಳಗಡೆ I have oxygen is present here. There is a certain extent of inductive minus negative inductive effect is operating here. Here I have Cl. It is still more than that of first molecule. Here Cl is abstracting. It is attracting the electrons. Here I have fluorine, which is more electronegative than the Cl. It is still attracts these electrons and becomes this carbon atom is going to become most stable because due to resonance, these pi electrons negative charge will be resonating towards the fluorine. Here you can see here 2 halogen atoms are present. Higher the number of halogen atoms or higher the number of most electronegative atoms, higher will be the stability of this carboxylate ion. This is called as carboxylate ion, C double bond O minus. This is called as carboxylate ion. So conclusion I must write here. Conclusion is higher the number of electronegative atoms attached. Higher will be the stability. Higher will be the stability of carboxylate ion. Higher will be the Stability of carboxylate ion. I think you have understood this one. So like this you have to trace out the questions. So once we done this one, we have next question regarding an electrophile. So this is considered to be a last question, 12th question, and it will be coming under the exemplar. Last question. Electrophilic addition reactions proceed. Electrophilic addition reactions proceed. Addition reactions proceed. Electrophilic addition reactions proceed in two steps. Okay. First step involves addition of an electrophile, addition of an electrophile. Okay. Name the type of intermediate. Okay, formed in the first step. Of the following addition reaction. So let me consider some of the options. See, they have given reaction CH3 CH double bond CH2, for which addition reaction is going to take place. We have to find out the proper product. Products are being given: secondary carbocation, okay, then B, primary carbocation, then C, secondary carb anion, okay, secondary carb anion, then I have D, primary carb and ion. So these are the options I have here. This is my last question from the exemplar part. So dear students, you can easily see here I have double bond. Always do remember, whenever we have unsaturated hydrocarbons, for those unsaturated hydrocarbons itself, this addition is going to take place. So here we have pi electrons. Pi electrons are sideways electrons formed due to sideways overlapping. They can be easily donated to H plus. So it is going to be donated to H plus. I think you do remember the Markovnikov's rule. This is H plus, which is generated from the unsymmetrical reagent. HBr, if you consider, H plus is generated. In that way also you can think, in other way also you can think here. Negative part will go and attack that carbon which contains less number of hydrogen. But positive part always go to more number of hydrogen. Double bond ಇರುವಂತ ಎರಡು ಕಾರ್ಬನ್ ನಲ್ಲಿ ಯಾವ ಕಾರ್ಬನ್ ಗೆ ಹೈಡ್ರೋಜನ್ ಜಾಸ್ತಿ ಇರ್ತದಲ್ಲ ಅಲ್ಲೇ ಈ ಹೈಡ್ರೋಜನ್ ಹೋಗ್ತದೆ. H plus will go. So what will happen? Definitely it will be directly attached to this carbon. So you can see here what is the product. See here CH3 CH, and then it will become CH3. It will be added to this carbon atom according to Markovnikov's rule, if you remember it properly. When unsymmetrical alkene is present, unsymmetrical reagent is added, then negative part of the reagent will go and attack that carbon which contains less number of hydrogen. What is negative part? Br minus, if you consider HBr, and this is H plus is positive part. It has to go this one. Anti-Markovnikov's rule, according to like that also you can think and write. So here what will happen? CH3 comes, and definitely this carbon is going to be possessing positive charge. You can see here this carbon is directly attached by 2 alkyl groups and 1 hydrogen atom. So I can say here this is considered as secondary carbocation. So which one option is we have here? we have secondary carbocation option. In your NCERT, secondary carbocation is given at the third and secondary carbanion is given at the first. But whatever it may be, I have just exchanged their places. Secondary carbocation is the correct answer, and I have explained it with a particular reason. So this is considered as the 12th question from the exemplar. I hope these all questions which I have solved here will be going to help you out for your CET preparation.